All right, now I'm on the bottom of page 376. Follow along. Describe a situation in which it would be more useful to represent a relationship with an equation than with a graph. So let's think about this situation. When would it be more appropriate to use an equation than a graph? Well, if you're dealing with fractions or decimals, most likely an equation is going to be better than a graph because it's harder to represent those partial numbers on a graph. It's harder to graph them, and it could be potentially harder to see. So that would be one situation where it might be more useful to just use the equation. So instead of taking, y equals 3/7 x plus 2 and making that into a graph, it might just be easier to show it as an equation. Okay. So what I want to write is if you are dealing with, now halves are usually okay because it's fairly easy to see kind of a halfway, but generally speaking, I'm going to say fractions and decimals better represented with an equation, but of course we can graph anything. If you are dealing with fractions or decimals, but again, you can still graph them. It's still possible to do. All right, let's go ahead and do number 1 and 2 now. Again, pay close attention. These are going to be problems just like the problems on your homework. Okay, they've given you the equation. Extremely important. They've told you what to plug in for x. So now you're just plugging in these values for the x and then seeing what you get for y, and then these are your ordered pairs. Okay, so they plugged in a 2. 2 minus 2 is 0, so they got a 0 for y. If we plug in 4, 4 minus 2 is 2, so we get a 2 for y. Plug in a 6 here. 6 minus 2 is 4. Plug in an 8 there. 8 minus 2 is 6. Okay, again, these are your x values. They always come first. These are your y's, so your x's are your run. So I'm going to run 2. And I'm going to go up none, which means I stay right there. There's my first point. Next point, I'm going to run 4. I'm going to rise 2. There's my next point. Next one, I'm going to run 6. Then I'm going to rise 4. There's my next point. Then I'm going to run 8 and rise 6. There's my last point. And that's all they ask us to do, graph the linear equation. Since they do want me to show that it's a linear equation, I am going to connect the dots and show that that can go on and on forever. Okay. Okay, next equation. They didn't give us our box, but that's okay. We can make one of those very easily. These are my x values. These are my y values. But Mr. Music, what do we pick for x? Whatever you want. Okay, so I'm going to start with 0. If x is 0, y is 0. 0 times 3 times 0 is 0. Okay, if x is 1, y is going to be 3, because I plug in a 1. 3 times 1 is 3. If x is 2, y is 6. If x is 3, y is 9. Excuse me. Now, you do also want to maybe look at the graph. Maybe picking 2, 4, and 6 would have been an even better idea because they have those numbers written. But I definitely wouldn't have wanted to pick like 10 for x because then I would have been off the graph completely. Okay, so 0, 0, that's going to be right here at the origin. and then I'm going to run 1 and go and rise 3, run 1, rise 3. That's going to be right there. Then I'm going to run 2 and rise 6. That's going to be right there. Then I'm going to run 3 and rise 9. It's going to be right there. And that's it. Now let's say, for example, you did pick 4. Well, then you're going to have 12, and that's going to mean your point's going to be right here. So again, oh wait, no, right there. It's going to be off the map, huh? 4, and then this would be 10, 11, 12 would be somewhere up here, and I can see that because when I graph this and make my line, there we go. So you can do these, and you're just picking X. I would always start at 0. If it was me, why not? Start at 0 and then go 1, 2, 3, 4. Boom, you got all your points you need. Okay. Again, at least 3 if they don't tell you how many to put. Okay, at least 3. So I at least need to do 0, 1, 2, and 3, and then I can have my dots and create my line. All right, thanks for watching. See you on the next one.